I don't think that the first one was recorded because at some point we get disconnected, and during that time I think the recording was stopped for some reason. I'm hoping this time stay recorded.
On the top, it said it was being recorded the whole time on the last one.
The last one, so I will check later on because it takes time. So if it was, then I will post it on YouTube, okay, for you guys, for the ones who came late, especially for winter.
All right.
Okay, and if you guys want to come back later on to refer back to it. I still have only 5 people in here. I'm still missing 7 more people actually. Okay, so we'll take the attendance later on. Okay, so before I do that, let me answer. I don't know if it's Gareth or I think Tim is the one who asked the question earlier about where to find the file. So let me just go back into my this thing in here to where we normally put files in here. Yeah, this is our session right now. I just uploaded see if you guys want to go back into the assignments. And right now I'm looking at the assignment as an instructor. Does it give you the option to choose the view in here? No, it does not. Or from home, maybe it gives me the option to choose the view. The view course, no, student view, okay. I just changed my view to a student view. So this is how you guys would see this. I'm just seeing it the way that you guys see it. And it doesn't show me that I made a change to the assignments. I'm going to go back into the assignments now. Let's see if that's, so it's going to be a lab, and the lab that I just changed is, oh man, lab 7. Okay, here is lab 7. This is due in 2 days. I'm going to click on it. And this is the file I just uploaded for you guys to look at it, I'm sorry, to start working with it. I'm going to open it right now. I'm going to open it in a new tab to see if it's going to be in this environment in here. It's not opening. Okay. Do you guys see the dialog box that just popped up or not? No?
Yeah, we see it.
Yeah, we see.
Do you see that you have chosen to open lab 7 or not?
Yes, yep.
Okay, so I'm gonna open it with and see if it's gonna open with, I'm gonna, since I have sharing Firefox, I'm gonna open it with Firefox. And I'm gonna choose that to just show you basically an example of what can go wrong, okay? So I'm gonna open it with Firefox. So at least Firefox was continuous enough, and it shows me a warning in here. This PDF file document contains form. The filling of form fields is not supported. So it was honest, okay? So it says in here, open with different viewer. If you try to use it with Firefox, it will not work, okay? But I'm gonna go back to its location and show you what could go wrong with this file if you don't follow the instructions. I'm sorry, I should have really put it in here that you must open it with the with Adobe Reader, okay? I guess I put plenty of warnings in the beginning, but hopefully you guys will know. I mean, that it's not gonna work. But let me show you, okay? So what is the file? It's in this folder in here. Let me share the screen with you. Oh, before I share the screen, let me open it first of all with Chrome and see if, okay. I just opened it with Chrome. Let me stop the sharing. Do you guys see Chrome popping up, or should I stop the sharing of Firefox and open Chrome?
We still see Firefox.
Okay, so I stopped Chrome and in Firefox. And let me share now Chrome. Okay, so now I have it with Chrome, and Chrome is not smart enough to tell me that this is a file it doesn't support, but it doesn't really. And it thinks it does. So I'm gonna put my name in here because it's giving me the what looks like I'm filling it, and you can fill it, okay? one of the things I can see very well, and it's actually shaded in here, a faint shade, that the fillable fields are shaded in here. So this is the objective. But because I know that this field is a required field, so I'm filling the required fields only. The others really don't matter. If you don't fill them, the file will say fine. But of course, you're required to answer those questions too. So this is the conclusion. So basically, I'm filling it using Chrome. Okay, I think I am done, and it doesn't give me the option to save the file. So what I'm going to do is I'm going to later come back to it and work with it. So I'm closing it right now. And if I the entire browser. So if I go back to the file and upload it, let me go back into it. And what is the folder? It's in this folder. I'm going to share this folder with you guys to see how the file is actually, where the file is located. And yeah, share. So this is the file right now. So if I open it right now, I worked on it. I did spend a few hours working on it. I did my report and I'm ready to submit it. So if I don't look at it again, I will submit this file and it's going to be like this when I receive it. This is how it looks like. It looks just as raw as you started with it. So we wasted a lot of, oh man, Chrome saves. No, this is not Chrome. Actually, this is when we did it in the beginning. You guys remember? Yes? Hopefully you guys remember. This is not what Chrome did. Okay? I changed the text in here earlier than this, and I put some stuff in here.
We just see your files.
Is it in, oh, I'm sorry, you're still looking at the file format. Yeah, so let me stop sharing that, and let me share with you how this file looks like right now after I close it from home. Looks like when we first opened it and we were working at 8 o'clock in the morning. So that's when we worked with it using actually Adobe. Don't use Chrome. Don't use Firefox. Firefox at least was kind enough to tell me that it will not be able to handle it. Do not attempt to use anything but dedicated PDF writer. If you're going to use this one, you can still use Chrome if you like. You're going to print it, scan it, and send it again if you like. Or get Adobe Reader, which is a free 100% free software from Adobe. Once you download it, you can use Adobe Reader. It has this nice feature to highlight the fields for you that needs to be filled, and it will tell you exactly the ones that are required in red. Use that and you should be safe. You should be able to save the file, and later on, basically, oh, I'm sorry, the ones I sent to you guys, and I need to overwrite it, okay? The one I uploaded earlier a few minutes ago has this information in it because it persists, it stays with us, okay? So when I saved it earlier, I saved it with this nonsense information. And the one I uploaded don't use it, okay? The one I uploaded had this details in it, which is not what I want you to do. So let me quickly update this file and let me leave the student view. Let me update this file because I don't want you guys to really send this file in here. Files, upload a new file, and it's going to be into the labs. And browse, and this one, upload. Okay, I'll fix it later on because for some reason it's not fixing itself. And also tell you, even give you the link for where you go and get the PDF stuff where you put it in there. Okay, but if somebody needs to volunteer and remind me sometime tonight or early tomorrow morning, because I have 2 more classes tonight, actually, one of them at 2 o'clock, another one at 7 p.m. And if I may not have time to do it today, I want somebody to remind me by sometime tomorrow morning that the file was not updated or was not there. That's going to be Tim's job now, since Tim is the one who was worried about where it needs to be. Do you agree, Tim?
What? I didn't understand.
Okay, Tim, here is your task, okay? You're gonna remind me by tomorrow if the file is not in where it's supposed to be, is not in the lab. Okay, because I removed it from the lab and the file is not there. Yeah. You're going to check on it and you're going to let me know. Everybody else, please do check to make sure that you guys have it, okay? I'm still missing 2 people in here. 3 people, actually. For some reason, they did not join us back. And they are Gino. I think Gino may have told me the reason. And somebody else. 2 other people. Okay. Anyway, and I think also Sophia is not here, somebody else. So, okay. First of all, before I want to continue, really, I want to ask you guys, I mean, the format that we're doing right now, how can we improve it? And you can go with the microphone, or we can go with the chat, if you like. Or is it working? Do you think the way that we're doing it is? Should we change it? Okay, chat thinks that it's working.
Yeah, this is working pretty well so far, I think.
Okay. Okay, so if everybody agrees that the way that we're moving, because I really don't want you guys to start feeling basically that we're not progressing, and that is really what is going to hinder this. I want you guys to really have basically learn from it, even though we're not doing it the way that I would hope to do it, but we need to move on, okay? So we're still talking about chapter 27. This recording, once it's done and if it's saved, I'm going to post it, of course, on Canvas too. I'm going to post it there. It's a good idea that you guys sign into YouTube so that the minute a new file is uploaded, you get an email directly to your Gmail account or whatever that you're signed in to YouTube. That way I don't have to basically wait for me later on to go on Canvas and post, like, hey, there is a new upload or something like that. You may have a more convenient time than when I posted to access this thing. So that's probably the only reason why probably you want to go on YouTube and actually be notified when things are updated. The drawback to that is that you will be notified about everything I upload. And right now, the 2 courses that I am actively uploading a lot of things for are this one and the astronomy class that I'm teaching at Riverside. So you'll be also knowing about stuff happening in there, but you ignore that if you want to. So, so we were talking about the basically chapter 27 so far, and we did problem 19. Do you have guys any questions about the problem we just did in terms of numbers and things like that? Everybody is good with that? So in here,
Yeah,
I'm missing Gino. I think Gino told me that for some reason he's got some work or something like that to take care of. And also Sophia, also for some reason I don't see her. Okay, and who else also is missing in here? Let me make sure that we have everybody in here. Julian is here, Jonathan is here, Gareth is here, Tim is here, Aaron is here, John is here. Who did I miss? Who am I missing? Okay, how about if I do a print screen in here quickly? That way I don't have to do this live. Anyway, So what's the next problem in the homework assignment? Okay, the question from Winter, it says basically that if we have problems with the PDF file, you don't even have to do the PDF file, okay? PDF file, I'm sorry. You can still do it the way that you feel more comfortable with it. So if you want to, you could use your normal basically stuff, except that it has to be using you need to upload stuff to Canvas. I really need it there, okay? I need it to be done by deadline. I don't want to really have it in email because sometimes email may block some content versus other, and I really want you to be able to go to Canvas and upload it to Canvas. So in terms of communications, I'd rather have you guys communicate through Canvas, okay? As much as possible. Uploading files, it has to be through Canvas, and especially uploading files, because when time comes for grading, I don't want to be scanning through my emails. I mean, before we were complaining about the amount of emails we received, but now I think it went, you know how the virus is going exponential, so is the email going with it too. It looks like there is a correlation between the two. The amount of email we're receiving at least is huge. So if you're going to send us an email, I might lose it. So please don't, okay? So send it via Canvas. So the answer is Canvas. Use Canvas.
Yeah, I tried using Canvas earlier this morning before I joined the class, and it said it was submitting, but it would never actually fully submit. That was my problem, and that's my concern for the future, is I'd like to be able to submit online, but I don't know.
Do you want to do a file so that do you want to share your screen to show me how this how it looks like? Yes or no?
I would have
pick
to
any file. Pick any file. I'm sorry?
I would have to go and upload it from my phone, because I used Canvas from my phone to try to send it, because I have a better camera on my phone than on my laptop.
I don't think it works to upload stuff from Canvas from the phone, because I tried that too. It did not work. So it has to be from a computer.
Okay.
So once you have it on your computer, send it to yourself as an image or something like that, and you can go to Canvas from your computer or from. I'm not sure about tablets, honestly, but tablets, I think they were fine because they have full-fledged browsers. I think it's not the browser as much as it's probably the chip itself. If it's an ARM chip, it's probably not going to allow you to do a lot of things. So
go ahead and I'll see what I can do, and if I run into any problems, I'll screen share.
Yes, yeah. Because I was thinking maybe it's something that I'm missing from my end that I need to do. That's why I was asking you to see if you can share your screen and see if that's going to solve it. Okay. So if you want to, if you have access to a file right now and you would want to, I can make you a co-host so that you can go and basically upload the file and see if there's something I can do from my end to make this easier. That's all.
Yeah, I'm I'll send. I need to upload the images to my computer first.
What I usually do, and this is probably may or may not work with you.
But
what I usually do is I have on my phone, I have it connected directly to OneDrive, which is or if you have a Google, I think Drive or any drive, you can connect to your basically cloud storage, and then you go on computer and you will find the file there and there in the cloud. So you grab it from the cloud and basically upload it to wherever you want to from the computer. So that's what I do, at least with my phone. I have OneDrive, which is, I have a lot of space on it. I have about 1 gig or more than a gig actually of space. And because of the limitations of Google, that's why I use Microsoft solution. I take the files, any files, pictures, videos, anything I do, files that I work with on the phone, and I basically upload them to, they upload automatically to OneDrive, and then from there, I pick them from there and work with them and do what I need to do with them and send them, attach them, do things like that. But to go back to the fundamental question is, please use Canvas, because even though you send an email and the email probably comes in and you may even follow up and tell me that you sent me an email, the trouble with it is that email will be buried under a pile of a lot of other emails. That's one problem. The other problem is email protocol sometimes blocks some type of content and limits the size and limits the type. And I don't want you to be having that problem. And it's going to be very difficult because I don't grade them the same day. I grade them all at once, I mean, later on. So you may have difficulty finding your work, and then it's your problem. It's yours. Then I assume that you didn't submit your work. And that's why Canvas will keep them all in the same place for me. So I go and grab them and start grading them. So use Canvas, please. The file format, it doesn't have to be anything. I like this file, actually, honestly, because it keeps things organized, the PDF file. And if you use it on the phone, it's not sellable anyway. So it has to be on a desktop. It doesn't matter which desktop, Windows, anything would work.
Related to that, there is actually a website where you can basically upload pictures and it'll combine a bunch of pictures into a single PDF file. And then you can email that to yourself.
Okay, you can do that. It's still, the trouble with that also is the text is not going to be an OCR text. It's not going to be recognized as a, it's going to be an image basically. Yes, that's fine, if you can do that. So basically what Tim is saying is that take the whole pictures of all of your pages, different pages, and send them there. As long as the pictures are visible, you can see them, send them there, and then they will be all combined in a single file, and then you can upload that file. You guys see the link that Aaron put in there?
Yeah, that's the website I use as well.
combinedpdf.com. Actually, I have the product that I got a long time ago, and it's called PDF Acrobat, which is really the file, the thing that uses the combine everything. There is actually another built-in now. If you have Windows 10 or anything like that, Microsoft has a printer, and that printer is called the Print to PDF. So you can actually go there on your computer and find that printer as just another printer in the as another option of printers on your computer, and print to PDF. And you can print 10 pages, as many pages as you like, all of them also on the same thing, and print them to PDF, whether Word, whether images, whether anything. And you don't have to go to a third party and upload stuff to another party and then do them. So print to PDF, there is actually another free printer. You can go and download called Qt PDF. That's a free printer. And there is another one that I forgot right now, but there is a, I mean, this is the Qt PDF you can go and download on your computer. And it's, make sure whenever you're downloading something, that's a general rule, you download something from a reputable download place, especially with Qt PDF, you have to be very careful. And Adobe Reader also, you have to be very careful. Adobe Reader, you have to download it from Adobe. Okay, you cannot go to anybody else and start downloading it from. So you need Adobe Reader, that's for sure, if you don't have the full version. Qt PDF, when you download it, make sure you download it either from CNET. That's a good place to download stuff from. That's usually a safe place to download stuff from. And there is also a, I forgot the name for it too, but it's actually not a repository for a lot of downloads. But CNET is a good place. Usually they screen their links to make sure that they don't, because Qt PDF itself is a free one, and some people, they make versions of it and they make it into different flavors, and they may have backdoor access to your computer, and you don't want that. So you want things to be safe. Okay, so make sure before you download something. But if you have a Windows 10 or later, Microsoft built into their operating system already a printer that is called Print to PDF. So you just print it to PDF and you give it a name and upload it from there and there. So if you can't do any of that, you go to, that's a good question, Aaron. Okay, Aaron is asking problem 72. Okay. So as long as you can always research these things and share ideas, and hopefully we can work together on this. Aaron, I'm gonna make you a presenter and you're gonna do this problem for us. How is that? Did you hear Aaron?
What happened?
You're gonna be doing the problem 72 for us.
That's what I'm asking you.
Let's look at what the problem 72 look like first. What is 72 here? Where is 72? 51. I mean, just because we're not meeting in class, that doesn't prevent you guys from solving problems. Okay, here's problem 72. Does everybody see what problem 72 is? Let me draw it for you guys. So problem 72 has a 0.012 kilogram. So we have a bar. Let me draw it, okay? And let me share this screen first. Share, we're gonna still share this screen in here. Okay, what kind of drawing tools we need in here? We want the straight lines in here. We don't want the one drawn by hand. So this is what looks like the x-axis for me. And let me draw another line in here. And this is the y-axis. Okay. I'm just drawing problem 72 if you guys have a look at it. So one of them is the x-axis and the other one is the y-axis. So this is the x-axis and this is the y-axis. And what else does it say in here? What is the problem? And there is a magnetic field that is coming out of the surface. Yes. So we're going to draw this one in here a little bit thin. Okay.
X is into the page, right?
X is going into the page, yes. So I'm going to Control C, Control B, Control B. Oops, I drew it in there. Control B. Oops, Control C. Anyway. So imagine that you have the entire pages full of this guys in there, okay? All of the space has this magnet in it that is going into a page. Okay. Okay, so the x-axis is on the bottom. The y-axis is the one for some reason it went away. And what else do we have in this problem? It says we have a bar of it's uniform. It has a mass of 0.012 kilogram, and it's nailed in the origin in point A. Okay, I'm going to draw the bar in here with a little bit thick thing in here. Okay, and I'm going to make it a different color. How's that? Okay. So it starts from the origin. Okay, so that's a bar. The mass of this guy is 0.01. Okay, Control V. I don't like to write that way anyway. So let me go back into to check the mass again. If you have the problem, you can intervene. So the mass in here is 0.012 kilogram. So we know its mass. What else do we know about this problem in here?
the length, which is 0.3 meters.
Okay. 30 centimeters, no?
Yeah, 0.3 meter.
Oh, you converted it already. Okay.
Yeah.
Okay, so we know its length is 0.3 centimeters. 0.3 meters, I'm sorry.
Yeah.
Yeah.
And B
Zero.
is,
Did they give us a value of B?
yeah, 0.15.
And
That's
B,
That's magnetic field, right?
magnetic field, how much? 0.15
Yeah, Teslas.
Tesla. Okay, so that's the value of B, and it's going inward. And so that's what they gave us. So the magnetic field is in the negative direction of the x-axis. If I do it this way, this is the x-axis, the y-axis, the z-axis is coming out. So the magnetic field actually, if I write it as a vector, it's minus 0.15 times in the k-hat direction. So we agree on the sign in here and the value. So B as a vector is equal to minus, with a minus sign, k hat. Okay. So we have the B, we have the, what else do they ask us in this problem in here? So we have everything we want. And what we need to know also is that it pivots without friction about an axis perpendicular to the bar at point A. So this thing pivots around the z-axis, okay? So this can spin around the z-axis. So this bar can go in a path that is probably like this, okay? Back and forth around this point in here, around the origin. So the origin itself is fixed. If we draw that as a different color, probably blue color. So this point now is fixed. Okay. Now, what else do they want us to do here? That's an important concept in here. When you're dealing with problems and you're seeing what you have and you don't have, one of the things in here, the key things in here, is pivots without friction. That means that that point cannot move. And since we're going to assume at some point that this is a rigid body, again, you see, you're collecting information in here, and that's part of the way that you solve problems. You're trying to find out what you have and what you know based on everything that is stated in the problem. What must be the current I in the bar for the bar to be in rotational equilibrium? When it is at an angle of 30 degrees theta, so they gave us an angle now of 30 degrees. So let's go back into the shape in here. So this angle, they said, is 90 degrees. I mean 30 degrees. So this angle is 30 degrees. Okay, so theta is 30 degrees. Okay, and this is in rotational equilibrium. From physics 250, what does that mean when it's in rotational equilibrium? You see, this is what they mean when you're solving problems and trying to translate what is given to you, what is asked from you, into equations, into a math, into basically things that mean something. Do you guys remember when an object is rotationally in equilibrium, what does that mean?
The two would be equal.
What is
Each other?
equal? I'm sorry, what is the equal?
The torque would be equal to each other.
They cancel, you mean? The sum of the torque, zero.
Yeah.
Okay, so that is basically what we need to know. So the torque must be zero. That's what this statement means. When an object is at the equilibrium, it cannot spin one way or the other. That means the torques, if there are torques, they cancel one another. One of them is trying to spin counterclockwise. The other one is trying to spin it clockwise. And these two numbers must be the same number in magnitude, opposite in direction, therefore the whole thing. I need a center of rotation. Where do you think I should take the center of rotation to be?
A.
The point A, the origin. Do I have to? Do I have to take it as A? Or do I have a choice in the matter?
Because it's pinned over there. That's why we're taking it.
You can't take it anywhere. There is a theorem that you guys probably did in physics 250 that says that you can take the central rotation anywhere you like, okay? And since the reason why that is, if I take this pen, for example, and this pen is not spinning, is it?
No.
If it's not spinning anywhere because it's a rigid body, it's not spinning on any other point. Because of that, then I can take this point as being the center of rotation, this point as being the center of rotation, this point as the center of rotation, this point as the center of rotation. I can take a point on Mars if I care to say that that point is the center of rotation because this one does not spin. And there is a theorem, and the proof for it is not hard to do in physics 250, where we basically show that if an object does not spin, if a rigid body, it has to be rigid though, is not in rotation around any axis, it will not rotate around any other axis that you can choose. So technically, there is a complete choice into where you put your center of rotation. However, for convenience, usually people put it where most of the courses give you 0. But in this case, we're going to take it around the pivot point because it's much easier to do it there, actually. And when you're doing summations, it's much easier to do it there. What are the forces? We need to do the free body diagram acting on this rigid body. They gave us its mass. They gave us its length.
There's a gravitational force.
Where am I going to put the gravitational force? Do you guys,
Downwards?
Negative
Where?
y direction, it says.
Where would I put the point of application of the force?
At B?
I'm sorry? At B? Is that where the mass gravity is going to act? Or at
Also
A?
at A?
Yeah.
Where the mass is, yeah. A.
Is it going to be A where the gravity will act, or B where the gravity will act, or somewhere in between?
Where the mass is?
B.
Sorry?
Where the mass will be?
Where
Because
is
As we said, we're rotating around
Because-
A, right?
F would be
Yeah.
mg, so you'd need the mass to have
where
the
we put mg? Okay, I agree with you that it's mg and it's pointing down. So this is the value of the gravity force. Okay.
Yeah.
Where am I going to put this starting point? Am I going to put it in B or A or somewhere in between, midway?
Does
anyway,
it matter?
It matters.
it matters.
I think it's B. I think.
Okay. Anybody else thinks that it's A? Or somewhere in midway? Yeah.
Mm,
Oh, it's at its center of mass.
Yeah, it has to be the center of mass. This whole rod, in terms of gravity, acts like a point particle whose location is actually the center of mass. So it matters where I put this. Because if I put it at A, it has no torque. Do you guys see that? Because the distance between the arm length is 0 of the force at A.
yeah.
And
Torque is R cross F, right?
I'm sorry?
Torque would be R cross F.
So the torque is going to be clockwise, isn't it? So gravity is trying to spin it toward the downward version. Okay. I'm not sure if I heard the question correct, but that's probably what you meant. If you.
Okay.
So that's the torque. So this is a negative torque. Okay. Now I need to find the torque of the force of. What other force do I have first?
The magnetic
Magnetic force. Which way is the magnetic force pointing?
into.
Okay. We have to work now. We have to do some honest work in here. Okay. So the current, there is a current in it or not? If there is no current, this thing is going to fall. Let me look at the question. I think we missed. You see, we have to make sure. Oh, they want us to find the current.
Yeah, we are finding the current.
So there is a current that is going to need, that we need in here to keep this thing from falling. Otherwise, it's going to fall. You guys see that? It's going to spin in persistence. So basically, you take it like this. And if you let go of it, it's going to go like this. And you don't want that. So you want the current in it to keep it from falling. So if this tries to spin it this way, gravity is trying to spin it this way, you want another force to keep it from falling, correct? Yes?
Yeah, so that
Okay.
would make the that would make the magnetic field go up.
So the torque of the magnetic field needs to be this way, correct? It has to be counterclockwise, otherwise this thing is gonna fall.
It'll fall, yeah. Okay.
Okay. So we know the torque, the force first. We need to find the force times the arm length. So we found mg, and we're going to multiply by its arm length, which is this length times the sine of the angle between this and that. So it's going to be a negative number. So it's the sine of this angle actually at the end of the day. Okay, sine of 30 degrees. Now we have to find this force in here that is due. So there is a current running through this wire, okay? I'm going to take it up to see if it can. So if the current is going up from A to B, moving from A to B, then the magnetic field is inward. So think about it this way. Magnetic field is inward. That will provide a force that is pointing this way. Okay? And that force will definitely have a torque that is a positive torque. That should compensate for that one. Yes? So far, so good? So the direction of the current has to be upward. Because if the current is going down, and the magnetic field is going into the surface, then the force will be down, and that's going to even help more the gravity to bring this rod down. You don't want that. We want the current to go up.
So you use the thumb as current?
I'm sorry?
Your thumb is the current?
Can you, I didn't hear you well because I think my speaker is kind of messed up a little bit. Go ahead, can you speak slowly?
Is the thumb current?
The current is going along the wire itself. It's going straight out.
No, for the right hand rule, did you use the thumb to be the current?
Yes, the thumb is the current. Yes, the I, which is actually L, from A to B. We're taking the current from A to B. So the thumb is A to B. That's correct. And the inward is actually going to be the direction of the magnetic field. IL crossed with B is going to give me a force pointing upward. That's going to give me a positive torque. Yes?
Yeah.
Okay, so we're good. At least we're clear on that. Now, the question is, this torque must be positive for the current to flow that way. The question is, and it's the same question that I asked earlier about the gravity, where would I put this force? Where would it act? Where is it acting at?
In the middle upwards?
Why? I mean, I can agree on that one, dealing with it as a point particle for the gravity, because the gravity, there is an argument for it. It points at the middle. But this force now, everywhere there is a charge moving, is acting on the rod. You guys agree that this force is along the entire rod itself or bar itself?
Yeah.
So I need to take an element of wire along the rod itself, okay? The rod has a length L. That's the formula we use usually. So instead of taking the entire L, I'm going to take an element, which I'm going to call DL, okay? And sum through this, because then I know exactly where the force is for this element. This is where the force is going to go. And this is not the entire force. This is just part of the force, because at the end, we're going to find the force for that element first, find the torque for that force, and then sum up all of the torques, because we're not dealing with forces really, we're dealing with torque. The torque for mg is easy to find. The torque for mg is going to be a negative number. It should be tau for the mg, or gravity, should be mg times the entire length divided by 2, because that's what the center of mass is, times the cosine of theta. Sine of theta. Okay? That is basically what the torque is. So, and theta is 30 degrees. So this is the torque, and this is a negative number because it's clockwise. Now it's the other torque that we need to worry about, and because this force is acting through the entire rod, so we have to find it for a small one, for a small force of length dl, and from there we sum up through the entire rod itself, and from A to B, basically the entire length. And that's how we find the torque, okay? So let's do that. So this is gonna be at a distance, we're gonna call it distance 1. I mean, it's a bad idea to call it, let's call it L. Oh man.
Are you taking the 30 degrees from the X and the bar from the A, or are you taking
Yeah, from
the 30?
from the x-axis to the bar. That's what it is.
But wouldn't you, when you drop the torque from the, I mean the gravitational torque, wouldn't it be the arrow pointing downwards and then red bar, and then the 30 would be from that red bar and the mg downwards?
Okay, oh, you're right. So this angle, oh, this is, oh, so, I'm sorry, so probably you're right. So this angle in here is 60 degrees. So that angle is 60 degrees, and this angle is actually, wait a minute.
No, that, we'll take that 30 the same way to be 30 up there, no?
So you can go on this one in here and write, okay? You are actually a co-host right now, Aaron. What you talking about?
Yeah, so if that would be the angle up there by the red and the bar, then wouldn't it be cosine?
Cosine of 30 degrees. Okay. The rule is for the torque again, it's r crossed with the force. So let's go back to the fundamental question. I think you may have a point in here. For mg, you mean? Okay. The torque for gravity. Tau for gravity as a vector is equal to r as a vector crossed with the force, which is in this case mg going down. Okay. R is going from and in magnitude, it's RMG, sine of the angle they form between one another. And the sine of the angle is this angle in here. And let's see how that is related to our problem. So this is the bar. This is the angle in here. This angle we know is 30 degrees or theta. This angle must be 60 degrees. And so this is a 90-degree angle. This angle also is a 60 degrees angle. Okay. So it's going to be a sine of 60 degrees and sine of 60 degrees, a cosine of 30 degrees. So this is going to be a cosine, you're right. Okay. So again, whenever everything fails, it's a good idea to go back into the fundamentals in here and correct yourself. So there is no shame in that. Okay, so cosine theta. Is that what you're saying, Aaron?
Yeah, that's what I was saying.
Yeah. Yeah. Okay. So it's fine. I mean, I hope everybody has caught this thing is. So what he's saying in here is that when we did the torque, when you guys did the torque in physics 250, basically you defined the torque as being the cross product of the arm length, which is r in this case, which is L over 2, the length of which crossed with the force itself, which is mg, in this order way. And the angle between them is sine of this angle, and the angle between them is a complement to theta, therefore the sine of 60 degrees, which is a cosine of 30 degrees. So in here, we should not have a sine of theta, but rather cosine of theta. Okay, let's fix that. Now, I have to worry about this force in here, the force F. And the force F itself, I'm going to take an element, so its magnitude for the element itself is given by I, because everything is perpendicular to everything. The magnetic field is perpendicular to the electric field, to the current, I'm sorry. So the sine of that angle is going to be sine of 90 degrees. So the force in this case on a single element is going to be the I times the length of the element itself, I took it to be dl, times the magnetic field, which is B. So we have that part. And the torque is going to be the distance. I'm using the symbol L. I really should use the length L for the entire rod. So the rod itself has a length L, which is this L, capital L, so that we can integrate over this small forces and how much torque they have. So, and then we have L times this force times, again, I need to worry about the sign of the angle between them. But the angle between them is going to be a 90-degree angle because of the fact that that this thing, the force itself is perpendicular to the current, and the current is along the direction of L. So again, in here, it's going to be the torque for the force of the electrostatic force, basically, is going to be the sum of all of this ones in here. But this is not the whole torque. This is just the torque of an element of that rod. So d tau is going to be L times I times dl times b. And now I have to integrate from 0 to a big L. So at the end of the day, once I integrate from 0 to L, from A to B, basically going from A to B, so the entire torque now, which is due to gravity, is going to be a positive number because I know it's counterclockwise. And it's going to be the integral from 0 to a big L of I B times LDL. Okay. And that should give me, of course, when I integrate LDL, in this case, it's going to be L squared over 2. And that should give me a value that is tau B, which is 1/2 of I times B times L squared. If somebody would have argued and said, wait a minute, this is as if the entire force of the magnetic force is acting at the center, okay, and making a 90-degree angle, they were correct. You guys understand? So we did all of this algebra, and somebody mentioned, and I don't know who it was, I think it's probably Julian, that why don't we put the force in the center of the rod? Do you guys understand? Was it Julian or somebody else who said to put it in the center of mass? Did you confirm? It was you?
Yeah.
Yeah, we could have done that and saved all of this algebra. But there was no reason for it, honestly, to be there, okay? There is no reason for it to be there, but algebraically, it came out to be the same thing. Namely, the force is IB times L, times sine of 90 degrees, because L and the magnetic field, they make a 90-degree angle because the magnetic field is going into the surface and the current is running through the wire, and the wire is on the plane. So in this case, there is a sine of 90 degrees between them. So it's IB times L. And the arm length is L over 2, because Julian thought that maybe we should put it in the center. There is no reason why it should be in the center, but the algebra turned out to be correct. So if you did it the way he did it, you're going to get the correct answer, okay? Well, it's just a matter of equating these two numbers with one another. Since you have B, you have L. And in this expression, you have also, this is the big L, not the small L. So since you have that two there, and just plug in all the numbers and you're going to find the value for the current. Does it make sense? Aaron?
So how do you find the current then?
You equate the two torques, the torque of gravity, which is minus mg L over 2 times cosine theta. In magnitude, it's going to be mg times L over 2 times cosine theta. It's clockwise. The torque of gravity is going to be a positive number, and you equate the two. You have everything. You have B, you have L, you have M, you have what else? G, which is 10. And you have theta, which is 30 degrees, and you plug in everything, and you should find the current. Okay?
I see. So you said you equate the torque of B to what? The mg?
Yeah. Aaron, do you need help with the screen?
I'm not able to control it.
Okay, you are. You are moving everything now. You are the one who's moving things. You want to access it? Yeah, there is an internet.
Can't get the drawing thing.
Okay. Can I help you with that?
Yeah.
Okay, let me. Okay, for some reason it's not letting me do that. I think sometimes the software itself is kind of. You want the pointy things in there? You want to write something, you can always type it.
Oh, okay.
Yeah, I'm clicking in here so that you can type anywhere you like. Okay, so you're using your mouse or your, yeah,
Yeah, I'm using my mouse.
kind of hard to. I use honestly the my thumb is much easier. My basically pointer is much easier than the mouse.
So you said like mg would be over here, and then what we were finding was the value of mg because it was tau equal to r cross f.
Mm-hmm.
Let me just bring my laptop here. And then what I was saying back then for the cosine one was that since the force was equal to mg,
Mm-hmm.
therefore mg is this. So I can get mg, which is the adjacent side, which is through cosine. So cosine of 30 is equals to adjacent over hypotenuse. So hypotenuse, we said it was L over 2.
Mm-hmm.
And then this was mg. So that's how I just knew that mg just equaled L over 2 cosine 30.
Well, if this works, and apparently it does, okay, you're good, okay? But of course, this is, I mean, dimensionally, there is something wrong with this expression. You see that, don't you? One of them is on Newton divided by meter, and Newton divided by meter needs to be dimensionless number. Hey, but if it's working for you, good for you. I think it's good. I mean, you got it correct. I can't complain about that.
Yeah. That's how I was saying it's cosine instead of sine.
Okay. I need you to be very careful because sometimes these arguments, they may work for special situations and they may not work for others. And because I think the way that you wrote it initially, this one in here, where you had tau equals to r cross f, this will save the day no matter what. Like when we got into trouble, when I got into trouble, not we. Let me take ownership of that and put a sign of theta because I was worried more about the electrostatic force, the magnetostatic force, honestly, than the mg. I was not too worried about that and put sine theta and didn't realize that that's actually the complement to theta that they should be putting in there. And so when you raise that question, because actually of this remark that you made, we went back to the fundamentals and we got it correct. Okay, so that's really how it should be. Okay.
Yeah.
Okay. Any other questions?
So, the part B is asking that which direction the current should go, from A to B or B to A.
It has to be from A to B because if it goes from B to A, the torque is going to be negative again, and the two negative torques will force this thing to go down. You see it?
So all we're using is the right-hand rule on that one, right?
Yes, the right-hand rule. Yes, the magnitude, the two torques, find them. I don't know why they put question B after in this order. Question A, you need to really resolve question B first in order to answer question A. Basically, you need to find the direction using the right-hand rule. Current is going this way,
and then into the page.
Yeah, the magnetic field is into the page, so the force has to be upward to provide a positive torque to compensate for the negative torque that is coming from the other one.
Because if we do it from B to A, that makes the magnetic force to go downwards with the gravity, so that doesn't keep it stable.
You need an anti-gravity for that to work, and we don't have that. Okay.
All right.
Okay. That's a good question that you came up with for problem 72. Honestly, I didn't, when I assigned this as part of your homework problem, I didn't know if it's going to be this involved.
He just gave us 10 questions. Should give us 5.
Well, are we men or are we mice? First of all, number one. Number two also is that I want you guys to learn. I want you guys to really be challenged. Okay? I don't want you just give you some of these easy problems like I give you the X and Y coordinate and tell you to do the product. That's not fair for you guys. You should worry about that when you see a lot of problems like this. Okay, and actually this problem in here, if you look at it, use your results from problem 2770, although I didn't assign problem 2770, but actually you really have to have an understanding of that, how that problem works to be able to answer this question. Okay?
What number?
If you read the question from 2772 from this homework problem 2072, it tells you to actually look at problem 70 because it's similar.
Yeah.
Okay.
Because 70 would give you the magnetic torque answer, which we just found, which is half IBL squared.
Yeah, which is I think intuitively sometimes don't discount your intuition completely. Intuitively, actually, Julian has found, actually, he said, put it in the center, forget about everything, okay? And that's powerful. So, Julian, do not leave intuition when you come into this problem. Sometimes it works. And you remember how I say at the end to discuss the results if it makes sense to you? That was actually a good point to go back and say, hey, it makes sense that I put it in the center and there. Where else would I put it? It doesn't make sense to put it in the A. It doesn't make sense to put it in B. For whatever reason, if you tell me it's A, I'm going to flip this thing because it's your uniform and switch B and A. So why don't I put it in B then? So the only obvious place that conserves this symmetry is actually the middle, the center.
Yeah.
You see how this argument of symmetry also put us back into the center? There is no reason for it to be in A then B or B then A. So the obvious place for it is to be in the center because everything is uniform. If I rotate this rod one way or the other, it looks the same to me. So the center is the only place that conserves symmetry.
Yeah, it simplifies like a lot of the work, huh? Also.
Yeah.
It's like
it's like
Gauss's law did the same thing.
Okay. Okay. Like I said to also Aaron, and hopefully everybody else is also picking up on this discussion. I know some of you are in here too. So. Like I said to Aaron, that argument he did, which doesn't make sense in terms of dimensions, it works, and it works in here, but always go back to the fundamentals. I mean, always go back to where we started from to make sure the algebra makes sense, and also the physics makes sense. I remember part of the question is at the end, does it make sense to you? That is where you come in and see if it makes sense or doesn't make sense. And it's not always true that it makes sense. Sometimes we come up with a velocity, for example, from the previous problem that is greater than the speed of light, or something that even if it's half the speed of light, you say, wait a minute, I got the answer, and I think the algebra makes sense. Does it make sense physically? No. This whole thing falls apart if I'm going to do it in terms of a different, the correct approach, if you wish. Okay. I want you to be thinkers. I don't want you just to be solving problems and answering questions and getting your grades and moving on. I want you to really be thinking all the time about this thing.
The reason why I thought about it was because, like, you know how for the Earth or like any large mass, the center of mass is basically at the center of gravity usually, right?
Yes. It's always a safe place. I mean, whenever you are asked to come up with something, whenever you're asked to solve problems, actually, it's always a good idea to make a simplified version of it. That's what really physics teaches us, is that take a problem that is very complicated, very hard to look at, approach it systematically, first of all, go step by step, try to understand it. And it's not always true that you understand it from the first run. You have to really go through it a few runs again, reading the question again. And once you have that understanding, try to put it in some sort of a model, simplified model, and see if it makes sense. The argument you just made, Julian, is a very good argument. Put things where they normally should, like the center. That's probably a good place for it. Because if anybody argues the other way, then you can flip around the argument by symmetry and find it somewhere else. But it's not always true that the symmetry would work. So you have to be very careful with it. You have to know what you have. Okay. I think we did a lot today. We're still meeting on Thursday at 11 o'clock, correct? So I hope that you guys will work the rest of the problems. And if you have any questions about this chapter, because we finished everything for chapter 27, I'll start recording chapter 28, and we should be done with this chapters 27, 28, and 29. The exam is basically right now 2 options that I'm facing: a project that is going to be like a you work on it through several days, or a take-home exam that you will only have about probably half a day to submit it, 4 or 5 hours with the open book basically, so that you can see the things. But that means that the problems will be a little bit more involved, and you may need all of these arguments that we just talked about to come up with the solutions and submit them in time. And of course, I hope that you guys understand that this hopefully will help you pass the class and also learn from the class too, which is more important.
Is that for the exams?
I'm sorry? Yeah, the exam. Yeah, this exam 5, remember we did exam 1, 2, 3. I'm sorry, we still have exam 4 first. That is chapters 27, 28, and 29. And then we still have chapters 30, 31, and 32, which are part of the last exam, exam 5, okay? So these are the 2 exams that remain for us, and we have to finish them.
We don't have a final?
We will have a final, yes. We will definitely have a final. And that's going to be exam 6, if you want to call it exam 6. So we still have 3 more exams. We did 3. We still have 3. In terms of content, we did more than halfway. We did 4 chapters of optics, and then chapter 21, 22, 23, 24, 25, 26, and we're finishing, if not finished, 27. So that's a total of 10 chapters.
After this chapter, we have 5 more chapters left.
Yeah, 5 more chapters. So we're in good shape. I think we're going to finish this course, and I think it's going to work fine. The only thing that is going to be an issue, and I'm still working on, I think I have a 50% solved, is the lab situation. And even with the labs, we did a lot of labs so far. We are technically short of 3 or 4 labs to make it also a full lab. So this course, I'm not too worried about it. So the other one actually that I'm teaching, but I have to worry about trying to come up with sources. So for you guys, you're in good shape as far as I'm concerned, and we should be in good shape. Please do ask questions if they're relevant to the chapters, if they're relevant to content, ask them in the discussion sessions so that everybody benefits from them, especially related to homework and things like that. I don't want you to be working in isolation, as I told you before. Ask questions. If somebody is willing to work with you on some problems, work remotely. Don't go and meet together somewhere in place and start working on problems. Observe all the requirements that the state and basically the government is asking us to do. That for your own safety and your family's safety, and that is very, very important. That's more important than anything at this point. And if you want to, we can open discussion sessions, for private groups between 2 or 3 people working together on coming up with common sense stuff for problems, homework, for homework problems and also for labs. And if you want me to be involved in the discussion, I'll be more than happy to. And if you want somebody else to be invited, that's very much good too. And also, if it's a question that is related to you only, if you have been, for example, scheduling issue or something that is needed for you, you may need to contact me. But there are some requirements in terms of sort of due dates that they cannot move. Those are, you have to work your schedule to meet those due dates. Okay.
Okay, thanks.
Thank you.
Thank you, guys, and stay safe.
All right, you too. Thank you.
Okay, thank you. Okay, bye.